Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at pure mathematics from Jinja Joint Mock. So we shall begin with question number 1. And question number 1 says the sum of the first n terms of the series this is 125 over 3n. Find the value of n. So we are interested in obtaining the value of n when the sum of this is 125n divided by 3. So let us look at the solution. So to begin with, we are given that the sum is 125n divided by 3, but we are given the terms as 3 plus 8 plus 15 up to n squared plus 2n. So when you add up these terms here, you get 125n divided by 3. So how best can we get the value of n? So we first need to analyze the given terms. So you realize from 3 to 8 there is a difference of 5. From this to that there is a difference of 7. So we cannot say that these terms here are in an AP, since the difference is actually not the same. Likewise, we cannot say that there is a common difference, because if you are to check for the common difference, it is not there. Then what about the common ratio? The common ratio is also not there, because 8 divided by 3 and 15 divided by 8 is not the same. So what do we need to do? So the next thing to do here, we need to look at the relationship between these terms. How are these terms related? Since the common difference cannot apply and the common ratio cannot apply, then we must know the relationship between these terms. Now, to look at that, you realize what you are given here is n squared, then this one is 2n. So you can easily see that since this last term here is in form of n squared plus 2n, then we can try to see if this first term can be created in this way. So if you have a 3, this 3 here can be written as 1 squared, if I'm to put it in this form, 1 squared plus 2 but times 1. So this will be 1 squared plus 2 times 1. Then what about this 8? So this 8 can also be written as 2 squared then plus 2 times 2. I want it to be of this nature. So if I begin with n equaling to 1, it means the first term I will get will be 1 squared plus 2 times 1. Then the next term will be 2 squared plus 2 times 2. And the next term when n is 3, it means I will have 3 squared plus 2 times 3. So you realize this follows the same suit up to when we have n squared plus 2n. So when you look at this value, you will actually get a 3. Because 1 squared plus 2, you will get 3. 2 squared plus 2 times 2, you will get 8. You realize that 3 squared plus 2 times 3, you should be able to get 15, because this is 9 plus 6, which is 15. So you realize that these terms here can be related in this way. But we know that the sum of all this is 125n divided by 3. Now we can have this written as 1 squared plus 2 squared plus 3 squared, if I pick the squares first, then plus n squared. Then we shall add there the next one. You realize we have 2 times 1 plus 2 times 2 plus 2 times 3 plus, and this goes up to 2 times n. And the sum here must give us 125n divided by 3. So looking at this, you realize this is something which is known. We already know that the sum of 1 squared plus 2 squared plus 3 squared plus n squared is a known sum. Likewise, we can try to look at this and try also to see that this 2 here is actually common throughout. So here we have 1 squared plus 2 squared plus 3 squared plus up to n squared. Then this one here can be written as 2 into 1 plus 2 plus 3 plus up to n. And this is 125n divided by 3. So you already know that this sum here is a known sum, and the sum of this first n squared terms, when you are adding 1 squared plus 2 squared plus that, the sum of this is given as 1 over 6n into n plus 1 into 2n plus 1. So when you add up the first n squares, then you'll be getting this sum. So plus 2 times the sum of the first n, the sum of the first n natural numbers, the sum of the first n natural numbers is also a known sum, which is a half n into n plus 1. Then this is equal to 125n divided by 3. So you have the sum of the first n square numbers. So the sum of the first n square natural numbers is this. Then the sum of the first n natural numbers is also given as this. So this is already known, this is already known. So we shall simplify this and get the value for n. So to simplify this, let us try to simplify this. We are interested in n, so we can multiply through by 6 such that we remain with n here, into n plus 1 into 2n plus 1. So I will multiply here by 6. So this will be 6n into n plus 1. I will multiply here by 6 and I bring this one this side, so it will be minus. So when we multiply here by 6, we shall remain with 2, 125. N times 2 should be able to give us 250n. So we shall be able to get minus 250n, which is equal to 0. So from here we can pull out n. So n is common, so we shall have n into, here we remain with n plus 1 into 2n plus 1, and then plus 6 into this will be 6n plus 6, then minus 250. So that is basically what we shall have, and this is equal to 0. So we shall have n into, so let us expand this to n squared, plus this will be n plus 2n, that is 3n, then plus 1 plus 6n plus 6 minus 250. So this will be equal to 0. So this will be same as n into, this is 2n squared. So let us try to simplify this. This will give us 9n. And then 1, this is 7 minus that is minus 243, which is equal to 0. So from here we can easily say that either n is actually 0, or you can write 2n squared plus 9n minus 243, which is equal to 0. So that is basically what we shall have. But since n will be representing the number or the terms that we shall be having, of course n cannot be 0. Otherwise it will not make any meaning here. So n equaling to 0 will be ignored. So we shall ignore n equaling to 0, then we deal with this given expression. So let us deal with that given expression. So we shall have 2n squared plus 9n minus 243. So when you solve this expression, you should be in position to get your n as either negative 13.5 or your n will be 9. So since we are dealing with the number of terms, so we shall have our n as 9, because when you look at the sequence which is given, all the terms that are that we are given here, you realize that the terms are increasing. So it means that a negative will not work. So finally we shall be able to conclude that therefore our n is equal to 9. So n equaling to 9 will be our answer.
Yeah.